So what if our exponents are negative? We're allowed to have negative exponents. Let's go back to our rule that we have for quotients. So when we have b to the m over b to the n, we said, oh, that's equal to b to the m minus n. Well, what if you have b to the 8th over b to the 10th? Well, then that's b to the 8 minus 10, which would be b to the negative 2. Okay, so that's true. You could have that. But generally, we don't like our answers to have negative exponents. Okay? So how could we look at this a different way? Well, again, I've chosen large numbers, but if you think about the canceling idea, you have 8 b's that are going to cancel with 8 of those b's. And so you're going to have a 1 in the numerator and b squared in the denominator. And so 1 over b squared, that has to be the same as b to the negative 2. Otherwise, we have problems with what we're saying in math. So we have another definition or a rule that says b to the negative n is equal to 1 over b to the nth. So when we have a negative exponent, it's going to put it in the denominator. Now, I said that, but you have to be kind of careful. At the end of this video, you'll see a little bit more what I'm talking about. It's all about location. Either you're in the numerator or you're in the denominator, and a negative exponent changes the location. All right, so let's look at some examples, and then I'll explain a little more. It says use the negative exponent rule to write each expression with a positive exponent, because usually they'll want the final answer to have a positive exponent. Okay, so this first one, we have a base of 9 and an exponent of negative 2. So I'm going to say, oh, that's 1 over 9 squared. Now, they most likely would want me to multiply that out. So 1 over 81. Okay, so now we go to the next one. The base is negative 2. The exponent is negative 5. So I don't want this negative on the exponent. So I'm going to write 1 over, but my base stays the same. I'm not changing that. Okay? So it's 1 over negative 2 to the 5th. Now you have to think about what does that mean. Well, 2 to the 5th is 32, but it's negative. You do it on a calculator. But you're going to get something like this. Now normally we either put the negative out to the side or in the numerator. So probably I would write it as negative 1 over 32. I would write it like that. Okay. If I have to put the negative in the numerator or the denominator, I would put it in the numerator. But you can just put the negative sign out to the side. Okay, now what about this one? And this is what we're going to talk about in a minute in my further explanation. You have a negative 2 for an exponent on that 6, that base is 6, but it's already in the denominator. So what it means is it's 1 over, and then just looking at this part, that's 1 over 6 squared. Well, how do you do fractions like that? A fraction within a fraction. Well, I'm going to keep the numerator 1, and then I'm going to use the reciprocal for 1 over 6 squared. So it's going to be 1 over, oops, it's going to be 6 squared over 1. Got to do the reciprocal, right? So you flip it over, like you're just bringing it up here and you're flipping like if we were in person, I could show you visually. You're bringing this to be the reciprocal, and you're making it multiplication. Another way to look at it, maybe you'll like this better. You have 1 divided by 1 over 6 squared. That's 1 times, and now you're going to switch their places. 6 squared over 1. Okay, that might work a little better. Okay, so 1 times whatever is just whatever. I don't have to worry about the dividing by 1. 6 squared, so it's going to be 36 is my answer here. Okay. So now I have stuff in the way. Well, that's okay. I'll just take this and look at it and say, all right, how many bases do I have? I have 3. I have a real number in the front, coefficient. I have a base of x, and I have a base of y. Now, if you're thinking, hey, that 7 doesn't have an exponent, remember you could write it 7 to the first power. It's still going to be 7, though. And it's going to be in the numerator. It doesn't have a negative exponent. But that x to the negative 5, see, that's got to be 1 over x to the 5th. And then my y squared, well, that's just going to be y squared. Now, if you like to put them over 1, sometimes students like to do that, so you can see the multiplying that's going on. In the numerator, I'm going to have 7y squared. And in the denominator, I'm going to have x to the 5th. Okay, so a little more explanation. I call it uptown, downtown. They call it a little bit different in the book. This is my own terminology here. But let's say you have something like 3x squared y to the negative 7 over, I don't know, x to the negative 3 y to the 3rd, something like that. Well, to make life easier, instead of writing all those fractions within fractions and getting it to be complicated, you could do two things. One, you could use the rule that we already have, the division thing. So 3, it's going to be x to the 2 minus negative 3, and y to the negative 7 minus 3. Okay, so that's the rule that we have. The rule says if you have b to the m over b to the n, that equals b to the m minus n. So that's what I've done right here for those exponents. It's 2 minus negative 3, and then it's negative 7 minus 3. Okay, so what's the answer? 3, that's going to be x to the 2 minus negative 3. That's going to be 2 plus 3, which is 5, and then y to the negative 10. Now you say, okay, well, I've got a negative exponent, so I'm going to move that part to the denominator, and I'm going to have 3x to the 5th over y to the 10th. Okay? And that would be the answer. That's a great answer. Now, what am I talking about uptown, downtown? Let me rewrite the problem. And that's a fine way to do the problem, by the way. But sometimes I like to do this. Okay, anybody that has a negative exponent, you're moving. You're either uptown in the numerator or you're downtown in the denominator. There's only two places to be. You're either up or down. Okay, so the 3, that's going to stay put, doesn't have a negative exponent. The x squared is going to stay put, that doesn't have a negative exponent. But this is going to move to the denominator. So I'm going to have y to the 7th. When it moves, it becomes positive. It's like he's not happy living uptown, so he's moved downtown and now he's happy. Okay, this one's going to move because it's not happy living downtown, so it's moving uptown. And then this, he's happy living downtown, so he's going to stay put. Okay, and then you're going to get the same answer from our rule of multiplying, right? You're going to add the exponents, 3x to the 5th, and then over y to the 10th. Okay, so kind of two ways to look at that problem, and you get the same answer.